And in this next section, I'm going to show you how an industrial hygienist traditionally used to make decisions and how it is comparable to Bayesian decision making. So, as I just mentioned to you, Bayesian decision analysis is focused on decision making. And so, regardless of the number of measurements and how we analyze the measurements, the end result is a decision. So, the exposure profile is in category 0, 1, 2, 3, or 4, and that decision leads to actions. And this has been the mode for industrial hygienists for a long time. It's only now that we are trying to make it more transparent and quantitative. So let's look at an example where there is an exposure scenario. The workers are exposed to some agent with an occupational exposure limit of 1 part per million. And there is an initial exposure assessment, baseline exposure assessment, and an industrial hygienist collected the following full shift data points. So there's 3 data points that were collected. So not a very large sample size at all. So n equal to 3, and the geometric mean for these 3 data points is 0.1, and the geometric standard deviation is 2. And the sample 95th percentile is 0.31. So 0.31 is much less than the exposure limit of 1 part per million. But the 95% upper confidence limit is 20 parts per million. So it's well above the OEL. And so the industrial hygienist now has a dilemma if he or she just went with the traditional industrial hygiene statistics. So if the hygienist just looked at the 95th percentile point estimate, he would conclude that this is a category 2 exposure. So the exposures are between 10 and 50% of the OEL. So this is a category 2 exposure. But the upper confidence limit suggests that the 95th percentile could be as large as 20 parts per million, so well into category 4. So what should the industrial hygienist do? So the point estimate is less than 50% of the limit, so exposures appear to be category 2, but the 95% UCL is considerably greater than the OEL. So what would the hygienist do? Make a decision or collect more data? And if our hygienist was very experienced, he or she would conclude that this operation is well controlled with just the existing dilution ventilation. And although the 95% UCL is excessive, our industrial hygienist took into account his extensive past experience with this type of operation. And his recommendations in this case are that further sampling is not necessary and routine surveillance samples should be collected using just the established schedule for well-controlled operations, meaning category 2 exposures. And so is such a decision making a Bayesian decision analysis? I would suggest that, in fact, it is exactly that, except the industrial hygienists in the past did not call it Bayesian decision analysis, but it shows all the characteristics of Bayesian decision analysis. We could put what this hygienist did in terms of Bayesian analysis. So using his previous experience, the hygienist says that this is a category 2 exposure, well controlled, but the 3 data points, 0.2, 0.05, and 0.1, they lead to a decision chart shown by the middle graph on the right-hand side. So you might notice that these graphs look very familiar to the one I've shown you previously. So there is 66% probability in category 2. And so if you combined the qualitative assessment and monitoring results charts, you will get the integrated exposure assessment suggesting that this is a category 2 exposure with 86.5% probability. So this is essentially what the industrial hygienist did, although it was all done in his or her head and in a not very transparent manner. So you'll see 3 additional things on this slide on the right-hand side. So each of the charts in industrial hygiene terminology, we call them as qualitative assessment, monitoring results, and integrated exposure assessment. However, Bayesian statisticians call these as the prior probability distribution, the likelihood, and the posterior probability distribution. So these are Bayesian terms for what these charts represent.